All right, let's talk about something you almost definitely have in your house right now, maybe in a drawer or a bathroom cabinet. We're going to do a deep dive on those common painkillers that we all seem to have on hand.
Have you ever really stopped to think about it? How does that tiny little pill just make a throbbing headache vanish? It seems kind of like magic, right? We pop them for headaches, muscle aches, you name it. But what's actually going on inside our bodies?
Well, it all starts with a little secret that's hiding in plain sight. It turns out that pretty much all of these common pills belong to one single, very powerful family of drugs.
Yep, from the classic aspirin your grandparents swore by to the ibuprofen you might have taken last week, they're all part of this one big family called NSAIDs. That's short for non-steroidal anti-inflammatory drugs. Now, scientists might slice and dice them into different subcategories, but at the end of the day, they're all on the exact same mission.
And what is that mission? To take on three main enemies: inflammation, pain, and fever. But here's the really interesting part. To understand how these drugs win the battle, we first have to understand why our body even creates these feelings in the first place. Turns out, it's all about communication. So let's talk about that communication network. Think of it like your body's internal alarm system. How does it actually sound the alarm when something's wrong? It all comes down to these little molecules called prostaglandins. They are essentially your body's emergency messengers. They're the ones that race to your brain to shout, "Hey, alert, we've got an injury over here." And that's what triggers the pain, the swelling, and the fever, all the things we'd rather not feel. This whole process gets kicked off the moment a cell gets damaged. You twist your ankle, you get a cut, anything that disturbs the cell membrane starts this chemical chain reaction. And right at the heart of that reaction is one very, very important player. And this is where the genius of these NSAID drugs comes in. They don't just numb the area or mask the pain. Nope, they're much more clever than that. They go right to the source of the alarm system and they find the off switch. Okay, so here's how that alarm gets made. When your cells are damaged, they release a substance called arachidonic acid. Think of that as the raw material for the pain signal. But on its own, it can't do anything. It needs to be converted by a special enzyme called cyclooxygenase, or, much easier to say, COX. Let's stick with that idea. If arachidonic acid is the raw material and those prostaglandins are the finished alarm bells, then the COX enzyme, that's the factory. It's the assembly line that actually builds the pain signals. And here's the magic moment. The NSAID molecule comes along and it physically blocks that COX enzyme. It's literally like walking into the factory and throwing a wrench in the main machine. The whole production line just grinds to a halt. No more working COX enzyme means no more prostaglandins